Hello?
Hello. Yeah. Hi, everyone, and welcome to the virtual SI session for CS146. And so we are taking these sessions to help everyone who is enrolled in CS146 under Dr. David Taylor. And since we know that Taylor's classes can sometimes be really challenging, along with the regular sessions that we are taking as an SI, we have introduced this new concept which is called as virtual SI. And both me and Raj will be taking those sessions. So we'll start off by sending you the attendance link so that we can keep a record of who all are coming to the sessions and who are the regular people, so that we can keep track of how people are getting benefited by using virtual SI. So Raj will be posting the link to the attendance, and then you guys can probably go there and fill in your attendance. Uh, yeah, here you go. So this is the link. You guys can click on that and fill that up, and we'll probably wait for like 5 more minutes to see if anyone else is joining. I can see there's one person who is already there in the session. Hello, can everyone hear? If every one of you can hear us, please send a yes on the chat. Okay, that's so it's a no or a yes. Okay, cool. So yeah, so I'm just making sure that I've given you the access to edit the sheet, and till the time I'm doing that, we'll just wait for like 5 more minutes. We'll start at around 3:40, so that if anyone else is coming in, we can cater to them as well, and then start off. Also, it would be easier for us if you can write your name in the chat as well, so that we can, address to you guys through your names. Like I can see that there's this username, but I don't know what your name is. So it will be easier to address to your problems and provide solutions once I know your name. So that would be really great. Okay, so we'll start the session. So hi Johnny. Uh, so the agenda for today is that we'll be covering intro to virtual SI. We'll cover how to insert a node into a 2-3 tree. We'll explain how we split a node, and we'll conclude the session and give a hint about what we are going to cover in the next session. So we have already covered the intro to VSI part. So we'll straight away jump into the meat of the meeting, which is inserting into a 2-3 tree. So to make it easier, what I'll do is I'll share my screen and show you. Uh, just दिख रही है मेरी? So what I'm doing is I'm sharing my screen. Okay, so the first thing that you guys can do is when you go on Google and when you type 2-3 tree visualization, then this first link comes up, cs.usfca. You can use this link by making sure that degree is 3, because if you go to degree 4, 5, 6, and 7, then what happens is it's different kind of B trees. So if we fix the degree to 3, it's like 2-3 trees. Okay, so you can use this to see visually how everything happens. So the insertion, the basic funda of insertion is that insertion always happens at the leaves. What I mean by that is, let's take some random values. Let's say we insert 10. So 10 is our root value. Okay. After that, we insert 20. So what happens is that 20 got inserted with 10 because we are dealing with 2-3 trees. Okay. So every node in a 2-3 tree can have 2 keys. So 20 got inserted in the same node as a second key. Okay. But what do you guys think? So what do you think, Raj? If I try to insert 30, what do you think? What do you think would happen? So what would happen is, I can pause this. So what would happen is, first it will try to insert 30 in the same node, but then it will realize that the number of keys in this node is now equal to 3, which is an illegal move, right? So what would happen is that it would split the node into one parent and two child nodes. So 20 will stay at the height at where it was, and now it will split the node into 10 and 30. You can, if you want to see these visualizations, I would seriously recommend you guys to pause the thing and then click step forward every time. So see, if we go 2 steps back, I was trying to insert 30, it tries to insert 30 in the same node, but then it realizes that, oops, now the number of keys in the same node are 3, whereas it should be 2. So it keeps 20 at that level, and it creates two child nodes, a left child node and a right child node with value 10 and 30. And then it does the insertion. Let's say now again I want to insert a value which is 40. Let's see how it happens. First, it goes up till 20. It's almost like a binary search tree, so it compares it to 20. That is it greater than 20 or smaller than 20? It's greater than 20. Okay, so now it goes up to 30, and it compares to 30. Since 30 doesn't have any child nodes, it gets inserted along with 30. Since we can have two keys, let's look at another option. What if I inserted 50? Again, it goes up to 20, checks is it less than 20 or greater than 20. If it was less than 20, it would have gone towards the left of the tree and got inserted with 10. Since it's greater than 20, it will go towards the right of the tree and try to get inserted in the same node which has 30 and 40. But this is an illegal move. Now this node has 3 keys. So what will happen is, again, this thing will get divided into two child nodes. But this is like the key step which you guys will be facing problem when you'll try to code this tree. So this is like 4 steps which have been skipped here. So you need to have a closer look. It was 30, 40, 50. And when I click step forward, the 40 goes up and 30, 50 are its child nodes. The important thing that we need to realize here is, how does this happen? So I would really recommend you guys, what you need to do is you need to think a solution to this problem, that how did this happen? So how did 40, how did we reach from this step to this step? Because if you are able to decode this, this program is like a cakewalk. But if you are not able to decode this, you can keep on writing like 800 lines of code and you'll not be able to reach what professor wants you to, or you will not be able to write an efficient solution. So you need to understand how we are reaching from this step to this step. And that would be more clear when we'll be studying split, which will be covered by Raj. So for now, you can imagine that whenever we are facing such a situation, what we are doing is we are pushing the middle element to the parent, and we have two child nodes. So in this case, 40 goes to the parent and we have two child nodes like this. Okay. So this is how an insertion in a B tree works. Now I would really recommend you guys to go on the website and play with a few numbers, because this would really help you guys into visualizing and understanding on your own how this happens. Also, once you are done with that, you can write it on the chat and then I can give you another example to explain the same thing.
Hey, so I have a little problem that I can give you, and so I'm going to type out a problem on the whiteboard, which I'm going to share right now. It's just going to be simple. We're going to give a few numbers and you want to insert them into a 2-3 tree. So with the current concept that Shivanku was talking about, you can go ahead and insert them and try to map out a result, and we'll talk about that example as well. Can you see the whiteboard? If you can, and I can get some confirmation with the chat, please let me know if you can't. So the problem we have, these are the keys we have: 50, 30, 10, 70, 60. So 50, 30, 10, 70, and 60. And what we want to do is insert these one after the other in this order into a 2-3 tree. So I'll let you take about 10 minutes to try to solve this problem. And if you have any questions, you can post them to the chat. And I noticed that, for this one, we just have one of you in here right now. So you can actually just unmute yourself and ask questions right away if you have anything. You don't need to keep yourself muted throughout, but if you're comfortable, you can leave yourself muted and post the questions through chat, and we'll try to answer them there. So go ahead and start trying to get the result for this. I want to insert 50 first, 30, then 10, and then 70, and then 60. Hi, so looks like we have Nick, who has just joined us. Nick, what we're trying to do is, I hope you can see a whiteboard. If you can, please post to the chat. That's how we can know the confirmation. So the question we're trying to solve here is, we have these keys. We want to insert them into a 2-3 tree in the order that's given. So we're trying to solve that till about 355. So try to map out a tree for yourself and how it would look like after you've inserted them into the 233. And okay, perfect. I see it. You can see it. So that's awesome. Do you have any questions? If you have a question, feel free to unmute yourself and ask it. We're not a big group on this for now, so you can post in the chat as well. Okay, so take some time and try to solve it, and we'll go through solution in about 7 more minutes. How are we doing so far? Have you all completed solving the problem? Or if you're running into issues where you're like, I don't know where to start, then let us know so we know if you've completed, we can move forward. If not, then we'll just give it a couple more minutes. Okay, so I think that was about good, and I'm gonna go ahead and start doing this problem through the visualization that we just saw Shivanku use. So can you see the visualization? Okay, so The first thing we wanted to do was insert 50. We have no root, so 50. So that's where the first check for insert comes in when we're starting off. There's no root, so we have 50 come in. And this is taking a little lag. Oh, that's what it is. I'm sorry, this is a technical difficulty here. I want to clear that. Yeah, there we go. So I have the 50 come in. The next thing that I wanted to do was insert let me see, I lost where I had it. 30, 10, 70, 60. So the 30, and since it'll go to the root as well. Then I wanted to insert the 10. 10 cannot go to the root because it's full in size. So it's gonna go and split off that node. And you see when you split it off, it always creates a new node with the middle element being the parent and the less being the right child, the less being the left child and the bigger being the right child. So that's a key concept of split. Like every time you split, you want to create a new node and this is how you split it. You don't do anything else. You just take those three values and you create a new node, send it out the left and the right, depending on which is bigger and smaller. And the next thing that I want to do is insert the 70. So absolutely, the 70 is bigger than the 30, so it goes to the right side. I'm at a leaf, so I can insert at a leaf now. And since I have room for an additional key in my right child, I can put the 70 out there. Perfect. And look at it, what happens now. Now is the tricky thing when I try to insert the 60. So let's see what happens. A lot of things happened right there. So let's take a moment, step back a little. Okay, so you can see it's at the 30, 60 is bigger than 30. So it's gonna go ahead to the right tree, subtree. Okay, now I'm at a leaf. I can insert the 60 in here, but what happens? I do that. Oh, but now I'm illegal because I have additional keys in there. I cannot have more than 2 keys. So I'm going to do a split. And you notice what happens with the split is that the middle element 60 splits off as one node with 50 to the left and 70 to the right. And we see that happen. And it kind of skips a step, like Shivanku said. But what happens then is that the 60 needs to be promoted back up. And when it is promoted back up, since we have space in that 30, it joined in with the 30 and then the 2 children. So now it's a node with 2 keys and we can have a left, middle, and right, and the 50 and 70 split up accordingly. Do you have any questions? Okay, so looks like that was good. Let's talk a little more about how that split is actually what happens once you split that. So Shivanku, do you want to take over?
Yeah, sure. So basically what happens is, as you can see Raj's screen, if we go a step back and we see the situation when he was trying to insert 60, I believe, right? So when he was trying to insert 60, what happens is we have this node now, this node has 3 keys, 50, 60, 70. So this is an illegal move. So what it requires is for us to split this node in such a way that the tree remains balanced and Yet we are able to retain the rules of a 2-3 tree, which says that no node can have more than two keys. So this is violating that rule. So how to go from this step to the next step? If we see, that would be, it simply tells you that 30 will now be having 60, and there are two new sub keys which are 50 and 70. So what happens is, there's one step in between which it is not showing, and that step is, just for a micro moment, what happens is, imagine this to be in such a way that 60 has two child nodes, 50 and 70. Okay. So just for a moment, you can imagine that 60 has a left child node. Raj will show that to you, or I'm trying to show that to you on whiteboard. Yeah. Yeah. So just for a moment, this is the split screen which does not showing you, which happens, which if you know, you will be able to program the problem fairly, efficiently and easily. So just for a moment, what it does is, it splits, since there are three nodes, 50, 60 and 70. So it splits it in such a way that 60 remains at the same height, but there are two new child nodes, which are 50 and 70, like this. But since this tree is not balanced, right? And the second rule of B trees, 2, 3 trees was that it should be balanced. So what happens is, recursively, when this call goes to the parent, which is 30, it tells 30 that, oh, I have split into child nodes, that I was a node which had two keys. I got another node, so I became three, and now I have split, and now I have two new nodes. So hearing this, what 30 will do is, 30 will absorb 60, and now 30 will have two keys. The node which was earlier just 30, now it has 30 and 60. And this is what is shown directly to you, even on the visualizations and also by professor. And that is probably one of the steps that you guys might be not be able to understand while you are programming. So what happens is, now 60 has two nodes, 50 and 70, which will be attached to the same node. So now we'll have three child nodes for this big node. The child nodes will be 10, 50 and 70. So if we go for a moment back to the visualization, so yeah, so if we try to forward it now it will be much more clearer to you guys. Okay, so the key thing for you guys to think about in terms of programming is, how do you convey this message from that child node to the parent node, that yes, I have split into child nodes and now you need to absorb me. If you are able to figure that out, your problem is done. If you are not able to figure that out and you try to find solutions which are somewhere around that step, trust me, some of your test cases in WebCat will fail. So this is the main scenario you need to cover. I'm sure the only hint I can give you, and some of students I heard in my section give each other, was take a bool value. So now you need to think, how will a bool value help you? How will a boolean value help you in communicating this to the parent through recursion, that yes, the child node has split. So this is the main screen that we wanted to convey to you guys, that understanding how a node is splitting is really important when you are programming that, because if you don't understand a split, will not be able to do it. Also, understanding that insertion only takes place at leaf nodes is really important, because when you are trying to insert a node, you need to reach till the leaf and then insert into that node. If that node has three keys after your insertion, then you need to do split. So you need to make your program in such a way that even for one moment, that node should be able to handle 3 keys, because even though it's illegal, it does happen for a moment of time. As you can see, even in the visualizations, the node does have 3 keys for a moment of time. So you should make your nodes in such a way that they handle 3 keys. And if they see 3 keys, then they split to make sure that one node does not have more than 2 keys. Okay. So I cannot stress enough on this point that you need to really think how you will be using this value and how you will be using the split function and communicating recursively to the parent what happens how. So any questions? If anyone is having any queries regarding this, what I just explained, because this is like one of your golden opportunities to understand if something is not clear. I saw many people during the code review who were little blank about what to do and how to do. So this is a really good platform for you guys to ask any questions, any queries that you guys might be having, anything where you are stuck. Okay, so Raj is going to take that case, and Raj will explain to you what happens if parent also needs to be split. Yeah, Raj, go ahead.
Okay. Awesome question, Nick. I like that. Something that I've come across, I've thought about it, and hopefully I have an answer for you. Let me bring the whiteboard back up for that. Okay, here we are. Don't mind my handwriting. I'm trying to do it using my touchpad. So I'm gonna actually, how do I get a little more space on this? Okay, never mind. I'm just gonna take out this little thing. Okay, that works fine, and draw. So you said insert an 80 first and then a 90. So let's see what happens. 30, 60, and we want to put an 80 in. So 80 is bigger than 60, so it's going to go to the right. And then we're going to have, it's going to come here, and wow, okay, I have space here. Let me put it right in here, 80. Okay, 50 stays just the same. And then I have my 10 here as is. Okay, awesome, that clear? And now we want to insert a 90. That's a little tricky one. Let's go about it step by step. So first I'm going to talk about it. And so the 90 is bigger than the 60. It's going to come to the right. It's going to see that, okay, I need to go in, I'm at a leaf node where the 70 and 80 is. I need to be inserted here, but I do not have room here. So what's going to happen is the 70 and 80 need to split off. So I'm going to draw what happens to the 70 and 80 just here. 70, 80, and 90. 80 is in the middle. So when I call a split, this is exactly what needs to happen. This is what happens to the 80. And the 90 goes here. And the 70 goes here. Okay. Awesome. Can you see everything? I just want to make sure I'm not. If you can just type it in the chat. Okay, superb. So we got the 80 there. So now I have a 30, 60, 10, 50, and then I have this little 80, 70, 90 thing. The 80 needs to get promoted to the 30, 60, and it sees that it does not have space out there. So the 30, 60, and 80 need to split off. What happens, it makes a similar split. So now my split, it actually happens, the 60 is the biggest, is the mid value. So here's what happens to the 60. It splits off into the 30 and then the 80, right? Okay, and now if you look back here, my 80 already is connected. The left and the right are the 70 and the 90. So this here is already my 70, and this here is already my 90. And before I make the split, I actually want to copy over. So this 3060 is actually at that point my current node. I want to copy over its layer. I want to make a new subtree with this 30 key. So before I do the split, I copy it. So I copy and I make a new node with 30 as my key, 10 as my left child, and 50 as my right child. Okay. So, and then when the split happens, the 30 has the 10 as the left, and then it has the 50 as the right here. And I seem to be running out of space there. Does that answer your question? Okay, awesome. So, you know, what's key in this position at this point is before making that splitting of that parent, I kind of want to make sure I copy off my left subtree into a new reference. And because if I just split it off, I lose out on my reference and I'm unable to go back. So before I do the split, I want to make sure I copy the reference to I create a new node I have the key. Absolutely. Absolutely. You got it. So you hold on, because when you're traversing through this tree, you have a current, and your current would be the 3060, and you make a new node with the 30, 10, 50. You already have a reference to the 80, 70, 90. You just split it off at that point and then create a new node again that says, okay, my new parent is 60, and its left child is actually the 30, which has a reference to the 10 and 50, and its right child is the 80, which has the 70 and 90. And when I need to make a lot of comparisons, decide which children will be replaced and what. You know what? No, because you're coming back up here from the right side. So you know that the 80 is always going to be bigger than the 30 and 60. The 80 will always be bigger because you're coming back up from the right side. So you know that the 60 will always need to go up. That middle element will always be the one that's going up. And the left child will always be the one that becomes its left child. So, and let me show you a little snippet of the code, and maybe that one I need to make a lot decided. Then the 30 will always get, yep, absolutely. The 30 will always get the 10 and 50 as its children. Always, always. You don't need to make a comparison for that. And likewise, this situation will also occur when it happens when you're coming back up. You could always be, at this point, how we came up from the right side, you could come up from the left side. And the same thing will be from the left side, because now you know that if you, for example, hypothetically, you were coming up from the left side, the 30 would always be the one that becomes the new child, and the 60 will always be the parent. The middle one would always go up as the parent. So here's I'm sharing my whiteboard. So give me 1 second before.
Till the time Raj is opening his whiteboard, also one thing you always need to remember is that 2-3 trees is extension of binary search trees, and there is one basic funda of binary search trees, and that is the left part is always smaller than the root and right part is always greater than the root. So your question gets addressed by the fact that at all points in time the left is always smaller than the root and right is always bigger than the root. So there will never be a situation when we'll have to make a lot of comparisons, because if we have, say, a big number which is greater than what we are searching, we always go towards the right. If it's lesser than the root, we always go towards the left.
Okay, so Nick, can you see this?
Where I'm making the copy, I've highlighted it. And this is the case where I'm coming up from the left side. I always make a copy and create a new parent, a new node right here. Can you see it? If you can see it, just hit me up with a yes. And then when I'm coming up from the right side, this is the copy I'm making. The case that we just solved, this is the copy that I'm making, and I'm creating the new node. So you want to, these are special cases. You want to make sure you handle these cases. All right, I'm going to turn that off. And so we have about 15 minutes left. This was basically what we kind of wanted to cover. Let me take the next 5 minutes, and you can unmute yourself if you want to talk, and let us know what you felt about the session, and if this was helpful to you.
Also, any feedback or advice or points you would like to share with us? We're always looking for feedback. Yeah.
Yeah, if you don't want to share it now, you can share the feedback later. We can send out a form, that's fine.
Thanks a lot. Thanks a lot, Nick. Yeah, that was the main purpose, to show that visualization, because many a times it is easy to miss that point which is in between, which even those visualizations were not showing, right? So it's important for you guys to remember that point while you are coding that, because if you take that case into consideration and also the special cases that Raj mentioned, you will be good to go. You'll clear all the test cases that professor might throw at you guys.
Yeah, I just sent out the link to the
visualization in the chat, so you can feel free to play around with that as
well. So in our next session, which is going to be like next Friday, it's going to be on 12th of October. So we'll be covering something in accordance to what you guys are facing problem to. So like in this session, we realized that many people are facing problem with 2-3 trees, and some people need clarity about how 2-3 trees are functioning so that they can code it. Okay. So similarly, we'll see at that point in time what is the current topic that professor is covering and what is it that you guys are looking for help in, and we'll take that topic So we'll really encourage you, and also Nick, you can tell it to your friends that you guys should really take use of these resources that Peer Connections and Professor is making available to you, because these resources are only given to the subjects in which it's a given that that subject is difficult, and using these resources will really be beneficial. So virtual sessions are meant to address issues or situations which can occur during 2 or 3 weeks span of time. So like we have this session every 2 weeks. So this cannot address your issues, like you have a new homework and it is really difficult to solve. Then I would really recommend you guys to come to our normal sessions, which happen for me on uh, Wednesdays and Fridays, and for Raj on Tuesday and Thursday. So yeah, please follow up on that. And thank you so much for joining us. Thanks. Bye.
Yes, on 12th, it's going to be at 3:30 p.m. And yeah, and it's going to happen bi-weekly. So from the 12th again, 2 weeks in on a Friday, it's going to happen at 3:30 p.m. So, if you can let other students know who are struggling and you think, and, they can make use of this. Any other questions? All right, then. Thank you for joining us, and we hope we could make a difference. Good luck. See you at the next session on Friday, the in-person one. Goodbye.